I am recording. Thanks for joining. This is our last session. Well, not our last session, but this will be the session that will conclude our syllabus for the semester. And then after that, we'll just have some sessions on revision. So yeah, I don't think we'll have a session next week, but then I'll keep you posted whether we will. But the week after that, yes, we will have one. If there's anything specific you want me to cover, any learning units that you want me to go over, please drop me an email. So I'll prep for that, because obviously I won't be able to cover every learning unit in the session. So I'd rather focus on what the majority of students are having trouble with. But yeah, let's kick things off. Let's start with the content we wanted to cover this evening. So we're finishing up learning unit 9, which is the chi-square distribution. So let me share my screen. If you can't see it, please let me know. So before I show you this question, let me kind of give you an idea what the chi-square distribution is all about. So let's say you owned a motor vehicle dealership. All right. Now in your dealership, there's essentially 4 types of vehicles, right? So you have vehicles that use petrol, then you have vehicles that use diesel, then you have hybrid that uses fuel or electric, and then finally you have a fully electric vehicle, which I'm just going to use EV, right? So you have a fully electric vehicle. Now, when you had this dealership 5 years ago, this was kind of the distribution. So I'm just going to write P for petrol, D for diesel, H for hybrid, and E for electrical. So if I do a bar chart, right, let's say this is what it was for petrol, right? That's the sales that you had for petrol. So on your y-axis, you're just showing the percent. So of all the vehicles you sold, this is how it's broken down. All right. Second, you had diesel. That was your next bestseller. Then you had hybrid vehicles, and then lastly, you had electric. All right. So it wasn't too much for electric. Now let's fast forward 5 years later. Things have changed. Now that same distribution, I wouldn't say same distribution, the distribution for these same type of vehicles now looks like this. So you have petrol here, you have diesel here, then for hybrid you have this, and then electric you have this. Right. Now, looking at the statistics here and the visual, what do you change your priority to? So this is now, and this is then. So here, if you look at before, you know, petroleum vehicles, the petrol vehicles would be number 1. Diesel would be where you would focus on stockpiling. Second, third, you would have hybrid, but not too much. And then 4th, electric. But now, if you look at it currently, you can see that electric is actually your best seller. So you would focus on stocking more of electric. Second priority would be hybrid. Third would be petrol. And then lastly, diesel. So can you see that this would guide you on how to manage your dealership, right? What you should prioritize in keeping stock of. All right. Now, what you've essentially done here, right? This view that you've looked at how the distribution has changed over something that you're interested in. And for you, in this example, it's your type of vehicles. That's what you're interested in analyzing. And you've assessed whether the distribution has changed. Now that's what a chi-squared distribution, sorry, a chi-squared goodness of fit does. Okay, so I'll write it out. Just give me a second. Cool. All right, so like I said, the chi-squared goodness of fit does this test. So it tests whether the distribution has changed. Distribution has changed. Okay, so one thing to note is that all this test will do is it'll tell you that it's changed, but it won't tell you how it's changed. Now, what I've shown you here, I've shown you that it has changed, and I showed you how it has changed, okay? But the chi-square test, the only thing it's interested in, it just wants to check, are these two the same or not? That's all you're checking. So that's what a chi-square test does. All right, so let me clear this and I'll do an example with you, a typical kind of example that you can be assessed on. So let me clear this board. And let me just check the chat if there's any questions. If there's anything that's not clear, please let me know. All right, so this is a typical kind of question you can get. All right. So a financial officer of an electronic goods company knows that from past experience, 23%, excuse me, 23% of its customers pay cash. Okay, 35% pay by debit cards, and the remaining percent, which would be 42%, pay using credit cards. Okay, because remember, the percent has to add up to 100%, which is why you would be left with 42% paying by credit card. All right. So that's the percentage of clients that pay by different payment methods. That's how it was before. Now, what this financial officer wants to do is this financial officer wants to confirm that this payment distribution method is still the same. So what this financial officer does, he or she takes a random sample, 200 sales receipts. And from those 200 sales receipts, the financial officer found that 41 pay by cash, 49 pay by debit card, and 110 pay by credit card. So if you add all these up, it'll give you 200. So this is what's given to you in your question, okay? Nothing you had to work out so far. It's just everything is given to you in your question, in the question. Now the question comes. Conduct a chi-square test to determine whether the distribution has changed. So that's what we're going to do. So just like in the example before, when I explained how vehicle types, how the distribution of vehicle types can change, here we're looking at payment methods, right? How clients pay. And this kind of test is quite valuable because in the industry, it'll guide you on whether to change the way you operate your business, right? Should you offer a different product? Should you focus more on an existing product, but just put more of your weighting and your energy and your finances towards that product versus a product that's not doing too well? So a chi-square test tells you that the distribution has changed or not. If it hasn't changed, then you can continue doing things the way you were doing before. But if it has changed, then it guides you on how to change your strategy. All right, so let's answer this question. Conduct a chi-square test to determine whether the distribution has changed. Now remember, last week, we did 2 chi-square tests, okay? So you get different types of chi-square tests. The one we did last week was testing independence. We also did testing for equal proportions. And lastly, now we're doing the goodness of fit test, GOF. Now, if you look at this question, it didn't tell you to conduct a chi-squared goodness of fit test. It just tells you conduct a chi-square test. So part of your assessment when you ask this question is for you to determine which test is it. Is it 1? Is it 2? Is it 3? And you have to be able to figure that out. What you need to know is when you're doing the goodness of fit test, you are assessing whether a distribution has changed. That's what the GOF test does. It checks whether the distribution has changed. And if you read the question, it says, test whether the distribution has changed. So you know that you need to use this test. All right, that's how you identify whether to use the goodness of a test. Okay, so let me just clear this out and then we'll start going through the calculations to answer this question. Yeah, just please, if you need to ask a question, just unmute and ask away. I'm going to just check the chat before I continue. Oh, good. All right. Right. So chi-square test, there are 5 steps to it. Let's do the first step. Step 1 is declare your hypothesis. Okay, you're going to have your H naught and you're going to have H1. Right, so your H naught and you're going to have H1. You need to remember that H naught is always going to be the case where the distribution is the same. So here you will say the payment distribution is the same. The same. And for H1, all you have to say is, if you already mentioned payment distribution in H0, you don't need to say it again. You just need to say distribution differs. The distribution differs. Or has changed, whatever works for you. But essentially, that's what you need to say. All right, so that's your H0 and your H1. Okay, now step 2 is to find your rejection region. Find the rejection region. All right. You are given your alpha, that is your level of significance. All right, so that's your alpha, which is 0.05 or 5%. And we need that to find the rejection region. So if we have to sketch it, the chi-square distribution is always skewed. So your rejection region is always on the right, just like as we mentioned last week, it's like this. So your rejection region is here on the right. And the size of that shaded area is 5%. 0.05, because that's your level of significance. So what we need to figure out is what is the cutoff point on the axis here. All right, now to find that point, okay, we need to use the distribution in the back of your book, the table. So let me just split my screen here and bring up my Word. And I'll show you them side by side. Okay, we need to use this table here to find the rejection region. Now we know from last week that we are going to use the second column. Why? Because your alpha is 5%. So that means you will use the column where the alpha is 0.05, and that's the second column. But which row do we use? Okay, so we need to figure out what our degrees of freedom are in order to determine what row we need to stop at. All right. Now, how you work out your degrees of freedom. Now, last week, I explained that to find your degrees of freedom, okay, last week it was df equals r minus 1 into c minus 1. However, you don't you don't use the same formula for the goodness of a test, okay? You have to use a different formula. So make a note of this, okay? So that's one of the big differences between the tests, okay? For the goodness of fit test, your degrees of freedom are calculated using this formula. You do have to memorize it, unfortunately, okay? I'm sorry about that, but you've got to memorize this. So your DF, your degrees of freedom, is equal to K minus M minus 1. And I'll explain what each of these symbols are, okay? K is the number of classes that you have. Number of classes or categories, same thing. Or categories. Now, if you look at our question, how many categories are there? There are 3 categories. There's cash, there's debit cards, and there's credit cards. So in this example, your K is 3. Okay, so your K is 3. Now, your M. The M is given by this table here. Now, I know I told you to memorize the formula for this. The other thing you do have to know is your different M's. All right, so what I can tell you to help you memorize this, okay, to determine what M is. If the question doesn't tell you that you're testing for a specific distribution, in other words, it didn't say anything about a binomial, it didn't say anything about a Poisson, and it didn't say anything about a normal distribution. These 3 distributions you covered in your earlier learning units. Now, if it didn't say any of those 3 distributions, then your M is always going to be 0. All right, so that's here. If you see these last 2 rows, it says user defined, and that's our case here. User defined just means it's not a particular distribution. That is, it's not a Poisson, it's not a binomial, it's not a normal. It's user defined in our case. So your M is 0. All right, you won't get tested on a uniform distribution. I've never in my history teaching this, and it's been a while, have I seen being tested for uniform. But a uniform would be the same thing as user defined, which is what we're doing now. Okay, so our M is 0, okay, shown in the last column. And then if it's Poisson, it's 1, if it's binomial, it's 1, and if it's normal, it's 2. What the M actually is, okay, so let me give you some context of what the M is in the formula. The M is it's the number of parameters you can't guess. That means it has to be given to you. That's what essentially it means. You can't guess or assume. So if you're dealing with a normal distribution, which we covered earlier, there are 2 parameters that you would need in order to use that distribution. You would need the mean and you would need sigma squared, because if you don't have this, you can't really use the Z table in the back of your book. You have to have these values in order to convert your variable to Z. If you recall, the formula is Z equals X minus mu all over sigma. So it means if you wanted Z, you would have to know this and you would have to know this. So that's what your M is telling you. Your M is telling you how many parameters do you need to know, all right? That's what it tells you. For the binomial distribution, right? And I know this might seem like a bit far away for you, but the binomial distribution has a parameter called P. So I don't expect you to memorize this formula here. Let me just give you an example. Your binomial distribution, you would need to have the number of trials and what's the probability of a success in this trial. So that means for each of them, you want to know what's the chance, say you were looking at whether customers would buy your product or not. So in other words, to work out probabilities for a binomial distribution, for that example, you would need to know what is the probability that they will buy your product. So that p-value is the parameter. So it's only one parameter. That's why your M is 1 for the binomial distribution. And it's the same for the Poisson. There's only one parameter, which is the mean, that you have to know. You can't guess it. All right. So that's just basically a breakdown of what M is. But how you determine it, you have to use this table here, but memorize it. It's kind of easy if you just remember well, this is the best way I can actually advise you to memorize it. Normal distributions 2 for binomial and Poisson, and those distributions you have done, right? So those discrete distributions, binomial and Poisson, those are discrete distributions. For that, your M is 1. Okay. Otherwise, your normal distribution, right? The normal distribution, M is 2. Everything else is 0. If you don't see anything mentioned about normal distribution, binomial, or Poisson, remember that your M is 0. If I could advise you, I would tell you that there's a very high chance, extremely high chance, that you are going to be dealing with a user-defined distribution. In other words, your M is going to be 0. That is the question that you're likely to get in your exam is going to be a case where M is 0, right? If you are doing the goodness of it test. Okay. All right, I'm gonna leave it at that. Okay, any questions before I continue? Nothing. All right, so we know our M. In our example, our M is 0. So K is 3, M is 0, and then the 1 you know. So we're just gonna plug all the values in. And if you work that out, you get 2. So that's our degrees of freedom. Okay, so our degrees of freedom is 2. So coming back to our table, remember our alpha is 5%, so second column. Your DF, which we just worked out, is 2. So there's 2 on the left margin for DF. Where it intersects, it's 5.991. So that is our rejection region here. Okay, so I'll write it here, 5.991. So everything above 5.991, we reject H0. And everything before that, I'm going to use a different color here, green, we accept H0. All right, that is step 2. All right, that isn't the bulk of the work. Remember, for the chi-square test, the most amount of calculation will be in step 3. All right, so now let's move on to step 3. So I'm just gonna, let me just, oops. I'm going to put the table here, as I'm going to refer to it again. And I need as much space to write. All right. So I'm going to go to a new page. Okay, so step 1, step 2 is done. We're going to move on to step 3. All right, step 3 is to calculate the test statistic. All right. And this is the bulk of your calculations for this problem. In this step, you'll get the most amount of marks, right? If you answer it correctly. So step 3. All right. We need to calculate the test statistic. Chi-square test. All right. So first step is to just write the table again in the question. All right. So in other words, the table that you see on the right, I have cash, and then I have debit card, and then I have credit card. And then I'll write out the values that's given to me. So you have 41 customers who pay by cash, you have 49 pay by debit card, and then you have 110 that pay by credit card. Now, these values that's given to you, that is what we call your observed frequency. So this is what the finance officer observed. When that finance officer looked at the sales receipts, that officer observed that 41 customers pay by cash, etc., etc. So this is your F0 column. That's your observed frequency. So what we need to work out is our FE value. So from last week, you recall the chi-squared formula for your test stat is sum. Okay, it's a sum of your FE minus F0 all squared divided by FE. Right? It doesn't matter if these are interchanged because you're squaring it. It doesn't matter on the order. All right. So in this equation, you can see that we need FE. All right. So we're going to have to work that out. Now in the question, right? If I go back, you'll see that the question, it gives you what the expected frequency is, but as a percent. That means if you read the question, it says they expect 23% of customers to pay by cash. They expect 35% to pay by debit cards and 42% to pay by credit cards. So in other words, I'm going to write a column here for the FE percent values, right, which is given to me. So here it's 23%. For debit cards, it's 35%. And then lastly, for credit cards, it's 42%. Now, using these percentages, I can actually work out what the actual FE value is, what the value is, not the percent. Well, how would I do that? Well, look at how many customers you have in total. If you add up the total amount of customers in the first column, they would have 200 because you looked at 200 receipts. Now, the question I'm going to ask you here to use your intuition, right? If you had 200 customers and you expect 23% of them to pay by cash, then what number do you expect to pay by cash? So if you know 23% of them are expected to pay by cash and you have 200 customers, then what is the number of customers that you expect to pay by cash? Can you write that in the chat? Give it a bash. I need you to try it out because you're going to have to do this in your exam. Okay, so given that bit of information, you knew 23% are expected to pay by cash, and you have 200 customers. One. Nice. Yes, you got 46 because that's right. How you did that is that you took 23%, 23% times 200, and you got 46. Very good. That's how you get your FE values. You just take the percent and you multiply it by the 200. So for the next one, it's going to be 35% times 200. And that'll give you 70 customers. And then lastly, you would have 84. For the last one, you can do it by multiplying the percent or just take the remaining customers. Remember, all of them have to add up to 200. So if you got 46 already, you got 70 already, then the remaining of the 200 will be lumped up in the last one. So you don't have to always work out the percent for the last one. All right, it's up to you. I'd recommend not to work it out. Whatever's remaining, just allocate that to the last class or category. Very good. Okay, so you've got your FE values. All right, now the next couple of lines in this table is nothing new to you because we did this last week. Remember, we need to, let me just make some space here. I need to create a column that gets the numerator for this formula. So I'm going to create a column here that's F naught minus FE all squared. All right, and then the last column is going to be F naught minus FE all squared divided by FE. That's my last column. All right, so let me just, can't, it's annoying. Let's just remove this part here, I don't need it there. All right, this is your last column. So yeah, we've done this last week, but I'll just do a quick recap. For this column here, right, you're just taking your F naught value. So let's do the first row so you have an idea. Your F naught value for the first row is 41, right? So it's going to be 41. And the FE value, the next value in this equation, for this first row is 46. It's 41 minus 46, all squared. All right, you work that out, you get 25. and you do the same thing going down the rows. If you do that, you're going to get 441 and then 676. And then the last column is if you look at this numerator here, I'm just going to circle this. That is just what you found in the previous column. It's the same thing as the previous column. All you're doing is you're taking the value from the previous column and dividing by FE. So in other words, the first value here, it's 25 divided by the FE value, which is 46. For the next one, it's going to be 441 divided by 70, etc., etc. All right. Now, if you do that, I'll just give you the values here. Write it out. The last column will be 0.543, 0.543. Next one will be 6.3. And then lastly, it's 8.048. All right, and then the last thing you need to do is add up all these values. You sum it up. You get a total of 14.89. Now this is your chi-squared test value. This is your step 3 done. You've done pretty much the bulk of the calculations here. The last part is just to interpret your results. Now I'll sketch the graph again, what we had earlier, and then I want you to draw a conclusion from this. All right, so let me sketch this graph. This is your chi-squared test. We got our rejection region here, right? Don't worry about the alpha because we already did that. And we said that the cutoff point is 5.991. So everything above it, we reject H0. And everything below it, we accept H0. So what do we conclude from what we found in step 3? Do we accept or reject H0? Anyone wants to give it a bash? Okay, so the question is, do I accept H0 or reject it? And I'll write it out again, the H0, so we can make our conclusion. So H0 was that the distribution, payment distribution is the same. It's the same. And then H0 is that it differs. Distribution differs. Or distribution has changed. Same thing. So let's see who says accept H0 and who says reject H0. Okay, good attempt. Right, everyone can see that your test value is 14. And it is definitely bigger than 5.9. Okay, 14 is bigger than 5.9. So that means it sits here on the right of it. It sits here. So it falls in the rejection region. So that means for step 4, we reject H0. All right, and then the last step is to conclude. Now, if we are rejecting H0, that means no, for H0, we are going with H1. That's what rejecting H0 means. So the distribution has changed. So we need to conclude this in words. Now our alpha was 5%, so we always start off with what our alpha is. So we would say at a 5% level of significance, all right, we reject H0. And conclude that the payment methods have different. Payment method has differed. All right. So the manager of the store would need to change their strategy, okay? Because payment methods are different, and you can see maybe they need to focus more on card payment systems, specifically credit cards. All right. Does that make sense to everyone? Everyone understands that? This is the chi-squared goodness of a test. All right, so remember, there are 3 tests for your chi-square distribution. There's the test of independence. All right, there's the test for equal proportions. All right, so independence test. Let's write it here. So you get your test of independence, which is pretty much the same as your test for equal proportions. Okay, it's very similar, these two. The only difference is your H naught. Sorry, your step 1. The only difference is your step 1 and your step 5. That differs, but pretty much the calculations are the same. And then today we did the goodness of the test, which is quite different from the other two. All right. Okay, everyone, the floor is yours if you have any questions. Please ask away. And that will bring us to the end of quantitative techniques and the content. I will give you a revision exercise by Friday. Yeah, please try that out and to test your understanding for this section. And then we'll start revision. Yeah, we won't have a session next week. If I do, I will make an announcement well in advance. All right, but then we'll start again the week after. But if you have any questions, if you want me to cover any specific learning unit, if there's something that you found challenging, then please let me know. I'm also going to try and structure the revision synchronous sessions to be more interactive. You know, I'll maybe try and play around with you trying to solve things in groups, and that'll kind of give me a good understanding whether you're following. But I hope you have been trying the revision exercises I gave you. That does help, okay? All right, that's it for me. I think I'm talked enough. But if you want to ask any questions, please feel free. Otherwise, yeah, feel free to drop off and have a good evening. Go for it, Buthelezi.
Evening, Mr. Moodley. I just wanted to know if you had missed the ICE task, is there by any chance where they will reopen again for us to maybe complete them?
Unfortunately not. I think it would have to be like a valid medical reason or something or any specific reason that would allow you to be granted an extension. But you'd have to appeal that with the EMERIS assist. But the marks have been captured already for ICE. So yeah, to answer your question, no, unless under those circumstances.
And how much percentage do they go into your marks?
I don't know it offhand. Your module guide has that, your module outline. Let me just see if I can find it. If you have your module outline, it will tell you the percentage. It even tells you the percentage for each of your assignments as well.
All right, thank you.
No problem. All right, everyone, have a good evening.